So 1.2, section 1.2, we're talking about square roots of non-perfect square numbers. Okay, so we spent a long time yesterday on 1.1, perfect square numbers. And we're going to get an example of a perfect square number here for our first example. But then we're quickly going to move to numbers that don't appear to be perfect square numbers. And what do we do with those? And how do we recognize them? So a non-perfect square number, okay, that cannot be written as a product of two equal numbers. Okay, so what is a non-perfect square? It is a number that cannot be written as a product of two equal numbers, and it doesn't have to be whole numbers or integers, just any two numbers. So, for example, 36. If we're talking about 36 as an area for a square, we know that 6 times 6 is 36. And so the side length of the square is 6 centimeters in this case, because 36 is a perfect square. Now, what about if the area was 30 centimeters? Okay, 30 centimeters. Well, the square root of 30. Okay, now if you do that on your calculator, first of all, we know 30 is not a perfect square. Okay, it's not a perfect square number. So if we were to try this on our calculator over here, turn that on, clear everything. The square root of 30 is this number right here, 5.477225575. Now there's no constant repeating parts of this. The decimal seems to be filling up the entire screen, all the decimal places that are available on this calculator. So it's non-terminating and it's non-repeating. So 30 is not a perfect square number, okay? So what we can do though is we can state an approximate answer, and this is what we normally do if we're trying to find the side length of a square. The side length is the square root of 30. That still is the value of the side length. But what it's going to be is it's not going to be an exact answer that we're going to be able to write. Okay? Now you will find out as we move through high school that just writing root 30 is an exact way of showing this side length. We're going to leave it as root 30, but not yet. Not in Math 9. We'll kind of deal with radicals. This is called a radical right here. It's with a square root like that or with a root sign. It's called a specific type of number. It's called a radical. We're going to deal with radicals in mostly in grade 11. So you'll just wait for that. But right now, there is a value that we can say, hey, if let's say you were making you have I don't know, you're a quilter, okay? Let's say you're a quilter and you like making sewing things. Anybody like quilting? Or have a mom or dad that does quilting? Okay, somebody put your hand up. All right, so if you're making a square, if you had to have an area of 30 square centimeters, you need to know how long the length of the sides of that square need to be. And of course, you just pump it into your calculator, and you would say, oh, it's got to be about 5.5 centimeters. Now, that is not an exact answer, is it? We have to round that. So we can state what the answer is, or the side length is, but it won't be exact. So this is important to note. We can't get an exact answer here, but we can estimate. Now, if you don't have your calculator out, and if you're not allowed to use your calculator, how would you go about trying to estimate? And that's what we're going to spend the next little bit of class here learning. So we're going to put our calculators away for now. You can check things, you can check. But how would we go about trying to estimate this square root? And maybe you've seen this before with benchmarks. You've heard of benchmarks probably before in some previous grades. And so benchmarks are simply, what they are known values that we kind of base our estimates upon, okay? So if I want to tell you how far my house is from school, and you know where the university is, okay? I would say my house is probably just a little more than twice as far as the university is from here. So that's my benchmark that you know about and that I know about. So if you go from here, our school, to the university, then if you go the same distance on the other side of the university or just a little bit more, you get to my house. So that's a benchmark. And we have benchmarks in math too. And when we're talking about square roots, we want to refer to those benchmarks that are the perfect squares that we know about. Okay? So this page here, you have in front of you in your notes there, it says to find the approximate square root, what we'll do okay, oops, wow, that's pretty wavy. Approximate square root of a non-perfect square, we would set up some kind of number line using benchmarks. So here are a perfect square list, and let me show you what I mean by using a number line using benchmarks, okay? So perfect squares are listed over here, root 30. Now, in these perfect squares that we have listed, where is the number 30? Because the squares, remember, would represent the number that's underneath that square root sign, right? So we run down the list. 30 is going to be, it's going to be right in between here, isn't it? That's where my 30 is going to be. Okay, so if I know that 30 is between 25 and 36, right here it says root 25 is 5, okay? So root 25 is 5, and root 36 is 6. Therefore, if the number 30 is between 25 and 36, the square root must be between 5 and 6. So here's the number line that I'm referring to. So if you write a number line, it's got arrows on both ends because the number line goes forever in either direction. And so let's say I have 5 over here and I have 6 over here. Okay? Now 5 is square root of 25. So I'm going to put that right above there. And this is square root of 36. So where would the square root of 30 be in this line? Would it be really close to 6 over here?
No.
Or would it be really close to 25? No. Or somewhere kind of in the middle?
In the middle.
Those look like two eyeballs, don't they now? Oh, cool. Somewhere in the middle. Okay, now let's think about this really carefully. Is 30 just a little bit closer to 25 or a little bit closer to 36? A little closer to 25. So, listen to this. Here's 5.5. That's right in the middle of 5 and 6. And I know that my square root is just a little bit closer to 5. So you see how 30 would be probably somewhere around here, the root 30. So you would make a guess at maybe 5.4 or 5.45 or something like that. Does that make sense? Yeah. Maybe really close to 5.5, but maybe just a little bit less. Okay, so let's say I'm going to say that square root 30 is approximately equal to, and these little wavy lines means approximately equal to, I'm going to say about 5.4. So it's going to be really close to 5.5, but I'm going to say just a little bit under. Now, what did we calculate earlier? On 5.477 or 5.48. So it's just under 5.5, so really it's really close. I mean, if we went to more decimal places, we could probably estimate just a little bit closer, but that would be a great estimate, okay? That's the kind of thinking that I want you to do. So how about that? Are you okay with that? That estimation? Okay? All right. Maybe we should do, let's see, what's next here? Okay, let's do another one. And on your paper here that you've got, estimate the value of root 15, okay? I'm gonna zoom in here a little bit more. Okay, so example 2 is estimate the value of root 15. So we're gonna do the same sort of thing. What are our benchmarks here? That is, what square root would be just under 15, and what square root would be just over 15?
Square root of 9.
Okay, just under so again, we're looking for perfect squares that are just less than 15, and you said 9, so square root of 9 would be less than 15. That's the benchmark that we know about. We know that that's 3, right? And what's the one just above 15? 16, right. So, and we know that that one, that square root is 4. So guess what? Root 15 is going to be between 3 and 4, or between square root 9 and square root 16. That's where it settles. Now, is it right between, or is it closer to one versus the other? Yeah, it is closer to 16. And for those of you who are like, what do you mean by closer? Well, this is exactly what I mean. Here's root 10 would be here, root 11 would be here, root 12 would be here, root 13, and so on, right? Okay, so that's what I mean. If those are evenly spaced, that's where the roots would settle. Root 15 would be greater than root 14 and less than root 16. So we are looking right about here. So maybe like a 3 point, what would you say? 3.9? 3.8? 3.9? 3.87. Okay, all right, that's pretty good. So 3.9. Let's just go to one decimal place and test, because you're right. It's probably going to be more than. Obviously, it's going to be more than one decimal place that we're going to see. But let's just give that a test here now. Square root 15, and drum roll, please. Oh, 387. Look at that. You're right on the money. You and your calculator out, maybe. Oh no, you didn't. That was a guess. Okay. Well, if you guessed 3.87, that was amazing. Good job. So 3.9 would totally be a reasonable guess. Even 3.8 would be okay. 3.85 or 87 is really, really close now. So square root of 15 is approximately equal to. Let's do wavy lines there. I'm actually used to doing this. Equal sign with a dot. That also means approximate. So, but I think this is the way they want you guys to show this stuff. So approximately equal to 3.9 or 3.85. So we'll say 3.9 is fine. Okay. All right, I want you to do this one without your calculator now on your own. What is your best estimate for the square root of 7.5? And I want you to show your work like I did here, okay? So map it out. Let your brain absorb this process. Give it some time to soak in what you see and what you write. So don't just throw down a number, please. Write out, map out what you're doing there. This helps your brain to understand the process really well. So try and do what I did here for this question. And then once you're done, you can check your answer on your calculator and see how close you were, okay? All right, so if you think about the square root of 7.5, the perfect square that's just under 7.5, I think would be 4, right? So you have root 4 on the one end, and then you have root 9 on the other end. And 7.5 would be a little closer to 9. And so you might guess that this square root is somewhere between 2 and 3, and definitely a little closer to 3. So if you guess 2.7 or 2.8, you'd be right on. Okay? So that's kind of how you estimate. So do number 4 as well here. It says, what's the value of 1.3? So you're gonna be able to be a little bit more precise. And what I'm saying is you might be able to go to more than one decimal place. You probably should. So estimate to more than one decimal place by using benchmarks again. So go ahead and do that on your own, see how close you get. All right, let's see how you guys are doing here with this. Now, some of you might have been tempted to go, hey, square root 0 and square root 4. Well, 0 is valid, and 4 is valid, but that's quite a big jump. What I want you to notice is that we can actually be quite a bit more exact with our perfect squares. Remember how we square decimals, right? So our perfect squares, and actually, can I just go back to that? Where was that list? Did we not have some kind of list here with the decimals? Hey, right here, look at that. So here's 1.21 and 1.44. You see that? And so 1.30 is right in between those two numbers. And so we're looking at, 1.1 and 1.2. So let's go back to this page. Where were we? Yeah, right here. So those are the two numbers you're going to pick. Okay. So keep that chart in mind there. Keep it handy. And so this is going to be, what is this? 1.1, right, as a square root, and this is going to be 1.2. So 1.3. Let's see here. So 21 to 30 is 9, so 0.09, and then 30 to 44 is 0.14. So 1.3 is going to be a little bit closer to 1.21. Does that make sense? Yeah. Okay. So it's going to be right about here, root 1.30. So it's going to be between 1.1 for a value and 1.2. Again, these are from our benchmarks because we know these are perfect squares. They're really close to this one. And so what's between 1.1 and 1.2? Well, this number right here would be 1.15, right? If you had another decimal place, this is like 1.10, 1.20. So 1.15 would be right in the middle. So if you guess something like 1.14 maybe, you might have guessed that for this square root, and that would be a pretty good estimate. So let's check on our calculator to see what it actually is. Let's see how close we got. Okay. Square root of 1.3. And 1.3 and 1.30, you don't, the calculator doesn't care. Okay, so 1.140. That's pretty good. That's pretty awesome. Okay, 1.140. So that's a great estimate, okay? Anybody have any questions about that? Yes.
What if you were to go between like square root of 1 and square root of 4?
Okay, if you went, okay, yeah, that's 1. Okay, so 1 is good here too. I did hear someone mention 0. But yeah, square root of 1 and square root of 4, you're not going to be able probably to get this precise, right? You would probably say, well, this is between 1 and 2, and that's all you know. You would just have to guess a number in between there, and you might say something like 1.2 or 1.1. Here you can get to 1.14 pretty easily. This one, your guess would be a little less precise, therefore a little less accurate. Okay? So if you have something like this and you have a known benchmark that's, you want to use the benchmarks that are as close as possible. That's the bottom line. Benchmarks that are as close as possible. Okay? All right. You guys doing okay here so far? All right, well, what about fractions, guys? What about fractions? So let's take a look at the second part of this lesson here. Estimating square roots of non-perfect square fractions. So what is the square root of 14 over 22? Well, 14 and 22. Can we reduce that? I suppose we could. We could go to 7 over 11. Okay, 7, 11. All right, so make you want candy right now? Is 7 a perfect square? No. Is 11 a perfect square? No. So this is not helping us here too much. But if we think about what are perfect square numbers that are close to these ones, and that's again where we go. We use benchmarks. So 14, okay, if we think about 14, I know that 16 is nearby, right? And let me see here. So 16 is nearby, and so is 25 nearby 22. Okay? So if you go up a little bit from 14 and up a little bit from 22, you're probably going to be in good shape to have an approximation, and that's what they did here. So you can do that. Now, benchmarks, yeah, you could do benchmarks too, which would be what? Let's see. So if we had a number just beneath 14 that's a perfect square would be what? 9, I guess? And the number just under 22 that would be a perfect square would be 16 maybe? Okay. And then on the right side of it, we would have root 16 over 25, right? So somewhere in between here and here is going to be the value of this, or somewhere between 3/4 and 4/5. Now that might be easy, it might be hard for you to find a number in between there, okay? You're going to have to do a little bit extra work to use those benchmarks. You're going to want to get them with the same denominator so you could really compare. Now it's not going to be too hard, but using benchmarks here, you're going to be good enough, it looks like here, just to use one benchmark that's close, okay? So with your decimals, you know that it's going to be between 3/4 and 4/5. But if you can find a perfect square fraction that's close to both these numbers, you can just use that one, okay? And so that's as close as approximating that you need to get here, I guess. So it's pretty close to 16 over 25, so you would guess it's pretty close to 4/5, okay? So let's try that method with these first two, and maybe I'll go a little bit deeper with you and show you how to be a little bit more exact with the third one, right? We'll see. So root 8 over root 15. So what are the square roots that are really close to 8 and 15?
9, 16.
Yeah, 9 and 16. And it helps that you go up from this one and up from this one. If you have to go up and down, that's okay. That's all right. But if you can go up and up, that's even better. Or down and down, that's even better. So this is going to be 3/4. So that's going to be your estimate, a little approximate equal to, obviously, because we're estimating. Okay? And what about B? Where would we go from B? What's the closest perfect squares to 10 and to 50? 9 and 49. Very good. You guys are getting quick at this. So that's going to be approximately equal to 3 over 7. Okay. And I am going to use this symbol because I just my brain does this. So that one's approximately equal to as well. Okay, let's do the benchmark one for this one. I don't know if this will help you or not, but let's see if this works. So for root 30 over 12, we have to go up to 36 and down to 9 for this one, right? Or we could go up to 36 and up to 16, I suppose. So that would be a good guess. So how could we use actual benchmarks though? Well, what's a square root that's just under 30 and just under 12? 25. Okay, so root 25 and root 9. Okay, so that's going to be about 5 over 3. Okay, that's what that one's going to be. And above, if we think about that, that's going to be 36 and 16.
Yeah.
So that's going to be 6 over 4. 6 over 4. Or 3 over 2. Okay, or 3 over 2. Now, this one should be somewhere between these two. Now, the tough part is, it's hard to know how close to which is it's closer to, actually. So, you know what I mean? It's really hard to tell, but we could guess somewhere right in the middle. What we'd have to do, though, is we have to get a common denominator between these two to truly compare them. So if I multiplied this top and bottom by 2, I would get 10 over 6. If I multiplied this by 3, which we actually just reduced that, but this would be 9 over 6. So it's going to be, oh, look at that. That actually is actually really tough. Between 9 over 6 and 10 over 6. Oh. How do we do that? Could we say 9.5 over 6? Whoops, 9.5 over 6? You could say 9.5 over 6. We wouldn't want to leave it like that, though, would we?
No.
How would I get rid of a decimal like this inside of a fraction? Sorry?
Add a 0 to the bottom.
Okay, if I add a 0 to the bottom, what would I have to do to the top, though?
Move decimal.
Yeah, so,
Multiply them both by 10.
okay, so you could, okay. So one of you said you could add a 0 to the bottom and then move this decimal place to the right. Yes, the reason why we do that is because we would multiply the top and the bottom by 10. So I just want you to be careful in memorizing some of those things, like add a 0 and move the decimal place. Really, that means you multiply both the top and bottom by 10. Okay, so, and that's a better one to think of. Let's multiply by 10 to get rid of that decimal. So now we have 95 over 60 is right in between there, isn't it? So 95 over 60. Okay, well, we probably could, you know, I don't know if we can reduce that a little bit. We could divide both by 5, I guess. This is what, 19 over 12? 19 over 12. Okay, all right, so that's a little bit of work, right? But that would be pretty close to what this answer would be, I suppose. Let's just check. The one way is to just say root 36 over 16 is going to be 6 over 4 or 3 over 2. And then I also have the benchmark way using the fractions, which is a little bit more work, but I get 19 over 12. So let's see which one's closer to the actual value. Okay, moment of truth here. So let's do, well, thank you. Square root of 30 divided by 12 is 1.58. Okay, let's check our 3 over 2. 3 divided by 2 is 1.5. That's pretty good. That's pretty good. Let's try 19 over 12. 19 divided by 12. Ooh. Oh, look at that. 1.58333. Oh, technically this one is a little bit closer, isn't it? 1.5. Nope, 1.5. That's 1.50. So this is 1.583. So this is a better estimation of what the root is. So using those benchmarks, the added wrinkle is make sure you get a common denominator to compare, and then pick a fraction that's in between. All right. So that's your best method. Right now, when you're first learning about this, just pick perfect squares that are close, and that's going to be the first level of good estimation. Okay? All right. All right, and yeah, for this last one, yeah, this would be definitely the best way to do all those. Okay, so the next page, what I want you to do is I want you to do these on your own. Use your calculator to determine each answer. What do you notice? I would like you to try not to use your calculator for some of these. All right, I would say for A, B, and C, don't use your calculator. No calc, okay? And then check. And these ones is optional. You can try to do this without your calculator, see how close you can get, and then check. But anyways, also consider this question, what do you notice? We'll talk about that in a few minutes. So 15.4 is really close to root 16, so the value should be really close to 4. And you might guess about 3.9. Interestingly enough, okay, this one right here, if you think about this number right here, on your calculator when you do this, you get 6.2 exactly. So let me just plump this up here, and I'll show you. So 38.44, oops, I'll do the square root of that, square root of my answer there. That's a long way. So look at this, 6.2. Now that is a terminating decimal, right? So remember, when we take the square root of decimals, if it's terminating or repeating, what does that mean? That means it's a perfect square. So this is exactly equal to 6.2. This is a perfect square. This is a perfect square. And what you'll find out too is that f is also a perfect square because it's a terminating decimal too. Okay? Now, 74.5, again, one more time. So what's just above 74 for a perfect square number? 81, right, 81. And then just underneath there would be 64. Okay? So it's going to be a little bit closer to 81, so that means the value is going to be a little bit closer to 9 than it is to 8. So approximately 8.6. So when we have a terminating or repeating decimal, it's a perfect square. And if not, we have to round the decimal, and that's an approximation. But please, I came around, there was still a number of you that are not using the benchmarks or are not understanding what we've been doing this class. Very important, okay guys? Very important that you understand what these benchmarks are, how to use them, and how to get your good approximations. All right, I will show you the homework for this section right here. It's also up on the website. Actually, let me just show you the website here right now. Okay, sorry. Right here, 1.2 is 1 to 8, 10 to 12, 15, and 19. Oh, 1 to 8. Hang on. Yeah, here's the homework for 1.2.